Hello and welcome to another video. Today we have two boards on our bench from a viewer. We have a Prime B550 Plus and a Prime A320MK. We are today going to focus on the B550 Plus first, and then we might see if we can repair the Prime A320MK. So, the problem with this board is a very interesting one that might be very hard to fix. This board draws too much current from the BIOS battery and it cannot save its BIOS settings. So he said the board boots are just fine and alright, but there's too big of a draw out of the BIOS battery and the BIOS resets all the time, every time. So what I want to do now is we want to check the BIOS battery, how much voltage it currently has. And it seems to have very low. Is this basically zero already? 2.8. So that is way too low. Everything below 3 volts I wouldn't use anymore. What I want to do is check resistance on the RTC line. So what we do is we check this tab right here. This tab should be ground. Yeah, this tab is ground. And this tab has high resistance. And then there's also a dual diode at the output that also has high resistance. So this is already a little bit more difficult. Let's check that there's a dual diode just close to the battery holder. And I just want to see if the diodes in there are okay. And that way seems fine. And that way also, let's check them in reverse. And in the other one. So the dual diode also seems to be fine. Very weird. Let's go under the microscope. I want to show you that area that I'm talking about. So this is the area that I was talking about. We have the BIOS battery, and this is a dual diode going from there to there. And what we have is one side will be the battery connector. Let's see now. Let's see. This is not it. Then it's probably this. Yeah, right there. That is the connection from here to here. And then there's a resistor, sometimes 1 kilo ohm, going to here. And then the 3 volts for the BIOS setting either come from the 3 volts from the PSU or the 3 volts coming from the BIOS battery. So what we would want to check is this place here against ground, but this will have high resistance. This against ground right here, also high resistance, and this against ground. This has also high resistance. Very, very, very weird. And the 3.3 volts also has high resistance. Let's check. What we can do is we can check the power draw of a board. So we put the battery in. We need to switch our multimeter to amps mode. In this case, we're going for milliamps. And what we do, with one probe, we push onto the battery, and with the other one, we push the tab back. And now we should see power draw, but there's basically nothing. Let's go into a lower range. Also nothing. And let's see in the lowest milliamp range that I have. We see an initial power draw, but there's no continuous power draw here. That is very weird. Let's check this behavior with having a CPU installed, if this changes as soon as we have that. So now we have a BIOS battery and a CPU in there. Let's see if the power draw changes. There's a big spike in initial power draw, but there's no big continuous draw. that I would expect that would like draw the battery out. Let's boot the board up and get into BIOS and see how it behaves there. We now expect the board should just normally boot up. So let's see now for the passive power draw if we can see anything on this board. So we have 150 milliamps, which is fine with the LEDs that we have. I want to check one more thing. I want to go into the resistance mode again. There's a clear CMOS header down here. And I want to check the resistance across it. And is that resistance really 0? No, but there should be voltage across it. That's maybe why we see 0. That is just 0.7. But I think we should see the 3.3 volts on here across it. Let's see again for the resistance. Is it really 0? That is very weird. When I'm in my 2K range from my multimeter, I get 0 across here. But as soon as I go into my 200 ohm range, I don't get anything. Interesting. We might have to see for a board view how that clear CMOS configuration is. But let's first see if the board boots up and how it reacts. So let's start it up. 2.1 amps, VGA LED. Oh no, that's a CPU LED that we have. Okay. Is this CPU supported or not is the question. Let's get a 3000G then into here. Let's see with a 3000G if we have more luck with that. Yeah, DRAM, CPU. Yeah, VGA, there it is. Okay. Let's wait for the BIOS picture here. And there's the BIOS picture. And let's see, I need to get that big on my screen as well so I can read what is actually written there. That is a CPU a new CPU installed, CPU fan error. Yeah, right, because there's not a proper CPU cooler on there. Okay, let's get BIOS settings into here so we can actually see that. Let's, for example, the time is the wrong one here. Let's change the BIOS to German, just to have something that we can change. So we're going to change this setting now and we're going to save it. So currently we only have a CPU fan header, fan error. Let me get a proper CPU installed into here, and a proper cooler installed into here, so that we don't get that error anymore and we don't have any overheating. So now the board was off for a few seconds or for like a few minutes while I was installing the cooler. And let's see if BIOS settings have been reset now or not. So let's see, new BIOS splash screen. And do we get a new configuration of BIOS? Please enter setup to recover BIOS settings. Okay. It seems like we are not... Our BIOS settings didn't save, right? And now we're not in German anymore. We are in English again. So let's do that once more. We're going to save German. We are going to reboot, see if the BIOS settings then already reset or not, or if it's only upon turning it off. And now it stayed in German. Okay, so while this system is powered on, that doesn't happen. So if we turn it off now, we're going to wait a few seconds. This is just standby mode. While the PSU still gives out 5 VSB. So 3 VSBs should also still be there. So let's turn it on again and see now if we still have the BIOS settings, or if it only happens as soon as we take off the power supply off of it. Please enter setup to recover BIOS settings. That was already too much. The BIOS settings are not saving. Interesting. So we have to take a closer look at the RTC section of this board. Let's see then. We need to trace some voltages with the BIOS battery. And let's go under the microscope then. So we need to go from here, from the BIOS battery. And let's see now. We want to see the 2.8 volts right there. There's the 2.8 volts. Then, after the resistor also, and after the diode, we also want to see about that. Okay, 2.6. That is also already dropped quite significantly. Yeah, 2.6. Let's see at the clear CMOS header. We only have 0.7. Okay, we need to see what draws. We might want to inject 3 volts into here and then see what the power consumption is. But first, let's go under a board view and see and analyze the circuit, how the RTC section, where what is going in this case. So let's do that for a second. So I only found a schematic, not a board view for this. But let's have a look at the schematic for the RTC power. So the most important ones is the VBAT, I think here, and the 3VSB ATX. So we see the B550 This is the dual diode that I was talking about right here. And what we have the voltage of the battery, then going to a 1 kilo ohm resistor. We saw that resistor. Then we have the battery holder, obviously, right here. And then V-bar, the battery, yeah, of course. And this then connects to the diodes. And we have this. At this point, at 3 volt battery, we had about 2.6 ohms. This is just another test point then there. And this 3 volt battery is the question, where does this all go to? So currently we see the SIO right here. This big thing is the SIO. And the 3 volts battery does definitely go directly into the SIO. So that could be a candidate here. Then down here we can see some capacitors as some filters. Then we see SKT OCC through a 2 mega ohm resistor going into the SIO as well, but that shouldn't matter as well. Then at the top right we have a case open, so a chassis intrusion thing also with a 2 mega ohm resistor, shouldn't really matter for us. So this is interesting. In a flowchart we see the 3 volts of the battery go into the AP2138N 1.5 TRG1, and this creates 1.5 volts RTC. We will probably have to have a good look at this then. And here's our circuit. This is a very convenient little device. It takes just the V in, then gives out V out 1.5 volts RTC. This is all in one small SOT23 package as far as I know. So we would have to check if this gives out the 1.5 volts RTC. But let's continue with 3 volt battery, where that all goes. So that was actually the last thing. So let's go further with the 1.5 volts RTC and see where that all ends up. So this then goes to the clear RTC section. So the 1.5 volts RTC. This goes through a 10 kilo ohm resistor and goes then to the RTC header where we saw only 0.7 volts, which isn't right. So there should be 1.5 volts at that section. Then we see another point through 1 kilo ohm resistor, which is VDD RTC. And we see AT12. That is just a test point. That doesn't matter. AT11 doesn't matter. These are test points for us. Then we need to check the resistance at the RTC header, which we saw was quite high, so above 2 kilo ohms. And we need to see the resistance at VDD RTC after this 1k ohm resistor. But let's first also follow where VDD RTC goes. No, let's first check if 1.5 volts RTC goes anywhere else. No, this is everything. Okay, then let's see what VDD RTC is. This probably derives just from the 3 volts, but I'm not too sure. Let's see. VDD RTC goes into the socket, so into the CPU also. 4.5 microamps this should draw. Okay. And that's it. It only connects to there. Okay. So what we will have to check, we have to check resistances for VDD RTC, for 1.5 volts RTC and the clear CMOS, and we especially have to see if this 1.5 volts are actually created like they should be. To check, we want to find SR36 and see on both of these sides, on side 2 and side 1, what voltage we have there and what resistances we have. So let's do this then. So this is our RTC header. So this right here is our clear CMOS header, clear RTC. And I think this is the device that we are searching for. The regulator for the 1.5 volts. So let's see now what voltages we have. We should have an input. This has nothing on it. That might be ground. Also not getting anything on this. And 2.6 volts here. So question now is, which pin is which? Let me have a look again. So the upper pin is the V in. So we definitely do get the power from the battery into here. So we have the 2.6 volts that are on the battery. And then the left pin is supposed to be ground. We can check that also. And we have a proper ground connection. Continuity mode. And checking the left pin right there. Do we not have a proper... There it is. We have a ground connection. And then we would want to see 1.5 volts on the right pin, which should be its output, which is right here. And we have 1.5 volts. So that works. So let's see then. At this point, we still should have the 1.5 volts. And at this point, we should have the 1.5 volts. And here we only have 0.7. So something on this line is pulling it actively low. So we should probably have a lower resistance on this line here somewhere. And let's see, this 0.6, 0.7. Okay, let's take the battery out so we can take some resistance measurements actually here. So we are in the 2k ohms range. And let's check right there. We seem to have high resistance, just like here. At this point, the 1.5 volts is still fine, but at this point, it already isn't. Okay, and let's check there. There we also have good resistance to ground. So we don't have a problem to ground anywhere. Our ground probe is correct. So at this point, no low resistance. Very weird. Okay, what we need to do is I need to inject 1.5 volts into that line and see for the power draw. The big problem here is that there's very few things that can draw the power here, and there's also very high resistance here. If we go like, let's go in the 200k ohm range, and let's see for the actual resistance here. If we look at the resistance right there, we have 9 kilo ohms. Oh, you cannot see that. Couldn't you see all the time when I took measurements? Cannot believe that. I hope I talked out the values all the time so you could actually hear those. So we do have 9 kilo ohms here. And just to show you again for the voltages that we are at the same plane right here, we have incoming voltage of 2.6 volts right there. This is from the battery directly. The battery is plugged in right now. Then this is ground, and this is the output 1.5 volts. And at this point we still have the 1.5 volts, and after the 1k ohm resistor we go to 0.7, and after another 1k which goes to the CPU we have 0.6, and the resistance here was 9 kilo ohms as we saw. So when injecting voltage we probably won't see too much in there, but I want to at least try. What we might be able to do is to take out this 1 kilo ohm resistor, place a lower ohm resistor, or even bridge it, so that this can give out all of its amperage, so the voltage doesn't break down here. And let's check for the resistance of that resistor as well. I cannot imagine for it to be too high. It should be a kilo ohm only. 10 kilo ohms. Is that right? I will have to check with the schematic, but that looks very fitting. Yep, that is supposed to be a 10k ohm resistor, and the one to the left of it is the 1k. Yeah, this is a 1k ohm resistor. Okay, and yeah, I will have to inject voltage into that point right there and see why we have 0.7 only there, why the voltage gets dropped from this thing so far. So I'm going to be connecting the 1.5 volts to that pin, and then we will see for the power consumption, and we will try with a thermal camera if we can see anything. Probably won't be seeing anything because 1.5 volts into 9 kilo ohms is nothing. So I currently have my power supply attached to there now. And now I want to see if the voltage stays where it should be. So at this point we should definitely have the 1.5 volts. Yeah, 1.5 volts. And at this point, no, we have it. Yeah, also here we have it. Just like there, we're going to have, this is now 0. 1.2, interesting. Maybe this works in reverse somehow. And there we also have 1.4 and 1.5. So there's something that is putting the resistance low to 9 kilo ohms. And 9 kilo ohms seems to be too low. I don't see a power draw at all from my lab bench power supply. There's 0.00 amps shown. So this is probably in the milli or microamps range. We can check that. We can check that with my lab band multimeter. Yeah, there it is. Now I can show you that is milliamps. That is 0.1 milliamps of power draw. There's no way to see something like that with the thermal camera, or to find out what that resistance, what takes that resistance. The only thing that we can do, we can go into the schematic, see where this line goes, and then heat the part up, and that might show us what is wrong here. Let's go under the let's go into the schematic once more to see for this problem. So let's see again. The 1.5 volts RTC, it does not go anywhere except that. So VDD RTC is the big other question. And the VDD RTC, it only goes into the socket. Does it really? But why is the voltage getting dropped so much then? I don't understand. Because there's this one capacitor, but this capacitor does nothing really. We have the 1K ohm resistor, and the VDD-RTC only goes to the CPU. VDD-PR, yeah, to the socket of the CPU. So let's see where VDD-RTC, if that goes somewhere else also. No, it doesn't. We only have it here. Only VDD-RTC is here. And the 1.5 volts RTC, yeah. What I want to do, we know this 1.5 volts RTC is there and is good. At this point, at pin 2, we still have 1.5 volts. But at SR36, we don't have that anymore. We get 0.7. What I want to do, I want to desolder this 1K ohm resistor right here. And I want to isolate it and see if then the voltage already goes down or not. If we then already have the 0.7 volts, or if the voltage then rises to, like, I don't know, 1.5 volts like it should be. Because then we can isolate on what string our voltage gets dropped. If it's here or if it's already happening here. So let's isolate that 1K ohm resistor. So let's now just delete that resistor right there, because it's just a 1 kilo ohm. That is nothing special. It will be easier. It will be easy to put one back if necessary later. But for now, let's isolate that and just quickly run this resistor off of here. The resistor is deleted. Let's now see for the voltage. We're going to plug the battery back into here. So let's see. We should have. So we should see the 2.6 volts still again here of the battery. Yep, that is higher than my range. Let's see. Right there. 2.7 volts. That already went higher than it was before. Interesting. Then here it's 1.5. Here it should be 1.5. And let's see right there. And here it's 1.5. Interesting. So our voltage gets dropped because of that. Because of what is happening after that 1K ohm resistor. So big question is that necessary? Let's go into the board view again. So what we found out is that this string right here at SR37, this 1 kilo ohm resistor going to VDD RTC is our big problem. There's just a single capacitor on here. SC3 2.2 microfarads. And going into VDD RTC, which only goes one place, which is another capacitor near the socket. Goes into pin AL15. And I would guess that we will see the resistance of the CPU if we probe this. And it should take 4.5 microamps. So the big question is, does the CPU need this voltage? It probably does, because they wouldn't put it there if they didn't need to. So let's check for the resistance at pin 2 once more, just to be sure, with and without a CPU. And then see if this board turns on without this 1K ohm resistor and if the BIOS settings are being held. So let's see for the resistance at that point. Yeah, we have 7 kilo ohms. That is like high. But I think it should go higher as soon as we take the CPU out. Okay, before we're going to do anything, I want to see if this board still is able to boot or not. Without that voltage, 1.5 volts going into the CPU. So this is the post screen from before. Let's now turn on the power. 150 milliamps. Let's see if it still turns on. Reacts to the power button. Power consumption looks to be fine. Let's see if we get a boot, but it looks very good. We have jumping power consumption. VGA LED. Oh, we don't have I don't have the screen plugged in. That's why it's complaining. Probably have to reset the board. So reset the board. Now have VGA on there. Let's get the keyboard also onto here. Now there's a post screen. Now let's see now. I need to switch my output from the microscope to the main board. And let's now see what our error message says. Recovering BIOS settings. Okay. We had the BIOS battery multiple times out. So let's recover them once. We're going to set this to German. We are going to press F10. We're going to reboot. Please enter setup to recover BIOS settings. That is still happening. Interesting. Our BIOS settings are already gone. No, they are not gone. Our BIOS settings are there. Okay. Okay, the BIOS settings did save, but we still seem to get that error message. Yeah, please enter setup to recover BIOS settings. When RAID configuration was built, ensure to set SATA. Okay, let's try something. Let's load optimized defaults of this board, because it's definitely keeping the settings currently. Let's load optimized defaults and reboot. Okay, same fault, but it's still in German, right? Yeah, it's still in German. Okay, we're going to turn off the board now. We see 150 milliamps. The board is off. We're just going to wait a few seconds. And now we're going to be turning the board. Let's, in those few seconds, see for the voltage that we have on that RTC header. Should be 1.5 volts. Yeah, 1.5 volts. And let's now hit the power button again. And let's see if we now still have the BIOS in German or if we already lost the actual BIOS settings. So we get a boot screen. It prompts us to recover BIOS settings again. And it's not in German anymore. So we did lose the BIOS settings with that. So it seems to be a different issue then. We will have to check if those 1.5 volts or if the 3.3 volts reaches the places that it needs to reach. I would guess that the SIO is responsible for holding the BIOS settings, so we need to see that the 3.3 volts reaches the SIO. So let's do that next then. So this might have been a red herring that we were chasing before, but let's then go into the board view again and check where that battery voltage is supposed to end up at. Probably at the SIO somewhere, and see if that battery voltage reaches the SIO. So turning the board off, and let's go into the schematic again. So the VBAT is supposed to get into the SIO right here. We will have to check that. That connects after the resistor, I think, to the second pin of the SIO from the top right. So right there. Oh, the board is still on. Let's take off the power consumption. So we see 2.9 volts currently at the battery. Yeah, 2.9 volts. Interesting that the voltage definitely did rose with disconnecting that resistor. So right there, I think this is supposed to be 0.15. I will have to check again if that is actually the VBAT where the battery connects to and goes there. Let me do some research. So I was wrong. The SIO is rotated a little bit differently. Where we need to go is the second pin here. So right this one. Yeah, 2.7 volts. So the 2.7 volts end up at the SIO. That is the big track that is here, I think. That you can see right this one. Yeah, 2.7 volts. Goes to there and here also. Yeah. So 2.7 volts getting in there. So, checking the VBAT, we know that all is present. So the VBAT definitely reaches the SIO at its pin, and we have VBAT only here. This is the actual VBAT coming out. Then we have test point and the battery holder. We have voltage reaching all of these places. Then the next place is the 3-volt battery. I would expect that wherever this connects is what actually holds the BIOS settings, because the BIOS settings either get held by the 3V's BATX or the 3-volt battery. So the 3-volt battery, it is connecting through a chassis intruder built-in front panel. So this goes through a 2 mega ohm resistor. It connects with a transistor and goes then to a case open to the SIO or to the chipset. I don't think that this will keep our BIOS settings. I don't think that this is responsible for that. So the next point is, yeah, this is just 3-volt battery that we have into the SIO. We have different points, 3-volt battery going to capacitors, but this is not shorted and this is also not keeping our BIOS settings. Then we have SKT OCC, intruder new CPU for 3 volts battery. This goes through a 2K or a 2 mega ohm resistor into the SIO. And I think if this wouldn't be present, the board wouldn't even start up properly. So this goes also into the SIO. We can check this area. So let's check at the this 2 mega ohm resistor, 01R24. So that is supposed to be that resistor which we see right here. 2.7, yep, and nothing right there, yeah, because we have a CPU and there's low resistance there. But yeah, we have 2.7 volts there, which is what we want to see. Next up in the schematic, the 3-volt battery goes to pin 73 used as case open. And this also goes into the SIO, I'm pretty sure. SLP S4 case open 1. We want to check if this is present and if this goes into the SIO and reaches that. So let's just go to the pin of the SIO, which is 73. And pin 73 is marked right here at the SIO, which is 1, 2, 3, 4, 5, 6, 7, 8, the ninth pin here. And then, yeah, the 9th pin. Let's see then here at the 9th pin if we can see voltage there. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. Okay, at the intrusion we don't have any voltage, but that might be because that's through a 2 mega ohm resistor. So let's search for the 2 mega ohm resistor. So this is the resistor that we had before, and this side is the case open. And we saw on this side that the 2.7 volts is definitely present here. So the case open seems to be just low resistance. Yeah, the case open is low resistance. 6 ohms at case open. And this is probably also, yeah, this is 1.5 ohms because of the CPU. This is the SKT OCC. So the only thing I'm not too sure about is if this is supposed to be that low resistance, the case open, 6.5 ohms. So what we saw, we have at this resistor, we have the voltage, and on this side, we don't have that. And this is going into the SIO right here, into the case open. But it is like for intruder and new CPU, I cannot imagine that this is the problem why we can't keep BIOS settings. So let's look the 3-volt battery further up, but all of this is nothing anymore. Yeah, and then only into the 1.5. So the only thing left for me really is to flash this BIOS, because it is chassis intrusion where this goes to, and I don't think that this keeps the SIO settings. We have 3-volt battery going into there. You know what? You know what we might want to check? Let's change out the battery for a new battery just to be sure that it hasn't over drained with that one resistor that we removed, and that is the issue. So the next two things that we are going to do: replace the battery with a fresh one and flash the BIOS, and then see if we still have the same problem. Let's do that. So looking at the, I've changed the battery out, and we have 309 volts at the battery. That is very good now. Let's now see if we go into the BIOS. If we're going to recover the BIOS settings once. I'm going to change the language to German, and then we are going to see if it now can hold the BIOS or not. So for now, I would expect again the message of BIOS settings need to be recovered. Yes. Let's now change this to German. We're going to reboot the system. Let's see if we get the BIOS recovering settings again. Yep. Still needing to recover the BIOS settings. So now checking, but the BIOS settings did save. It's still in German. So let's go for load optimized defaults once more. Optimized defaults are loaded. Let's change this. Okay, still wanting to recover BIOS settings, but I think it still will be in German. Yeah, okay, let's now turn this off. So now the BIOS is off. The board is in standby mode. A few seconds, let's turn it on now and see now if now the BIOS settings are actually reset. And still wanting to recover BIOS settings, and let's see, is the BIOS reset? Yes, the BIOS is reset now. Oh, well then, next option for me would be to flash the BIOS chip. So I'm going to do it via the, I'm not going to use the inbuilt version of the BIOS flasher. I'm going to be flashing it through either through the header that is on here, or I'm going to desolder the BIOS chip, and I'm going to be trying it out like that. So let me try that. So the BIOS is now flashed. Let's see now if we get the same behavior as we had before. So we are looking for not getting a problem with the BIOS. And now it went directly into the BIOS. That is very good to see. Interesting. Let's change this to German again. We're going to save this BIOS. We're going to reset. Let's see if we get a BIOS error now. And we don't get a BIOS error. It is in German. Let's turn this off now. We now have passive power consumption, and as soon as we went to passive power consumption, we lost BIOS settings. Let's turn it on again. Board is turning on. Let's see if BIOS settings need to be recovered. BIOS settings don't need to be recovered, but did it keep the BIOS settings? It's not in German anymore. Let's change it to German once more. But we don't get the error message anymore. Okay, now it's in German. Let's see now. Let's turn it off. Passive power consumption. In passive, we are on standby. Let's turn it on now again. So no error message, and we're not in German anymore. Let me let me change a different setting, because the BIOS settings are not getting reset because the time in the top left is keeping. I think this might just be a setting that changes all the time. Let's go here. No, let's not change the voltage. Let's go into a SATA configuration. SATA port enabled. Let's disable all these SATA ports. Let's save this. And let's see now if it keeps this setting. So let's see now. Did it save the SATA configuration? Yeah, it saved it. So we're going to turn it off now. Let me put another heatsink on it because the CPU is getting quite warm. So after a few seconds of standby, let's now turn it on again and let's see if those SATA settings are being reset. And let's now see. SATA is enabled again. The BIOS settings reset. I do not know what could be the case for that now. One more thing I want to check. We now the board is in standby. Right now, not even in standby anymore. Right now I turned everything off, which means the only place where it could draw power from is the battery now. And let's now see if it now is going to keep the BIOS settings. Or not the BIOS settings, but not throw an BIOS recovery error. So let's see now. Turning it on again. Let's see if we get an error. And we instantly go into the BIOS. So that problem is not happening anymore. But we also not keeping BIOS settings. But the time isn't reset. That is so weird. Is there a way to flash this BIOS? No. Yeah, only through files. So the main problem, as far as I know, for the viewer was that that the board always wanted to recover BIOS settings. That was, I think, his biggest problem. Let me get the email again. Yeah, the biggest problem for him was that he had to always confirm the BIOS settings after every restart, and that is not the case anymore. But there's still something weird. This issue might reoccur because the BIOS settings aren't saving. But if you're using default settings, this might be fine. And let's see if this board goes into Windows without us needing to go into the BIOS. Because that's, I think, the biggest problem here. Yeah, it instantly goes into Windows. I'm at a loss here, to be honest. So I know BIOS settings are stored via the SIO, I'm pretty sure. And because the SIO is being fed by the 3 volts of the battery. And that is reaching. We do know that. The BIOS chip itself is only ever being accessed by the SIO. The 1 kilo ohm resistor that we took off for the CPU, I do not know what that is for, why that is there, or what it is doing. Because it's now missing and I don't see a difference. I don't see any change with that. And we saw that after that, the 1.5 volts was drawn down heavily because of that. Yeah, I just don't know, to be honest. I do not know why this is not saving BIOSes. But it definitely is booting reliably here. Let's turn it off once more and try to turn it on with the Windows installation in there. So we're going to go away from passive power consumption. We're going to press the power button a few times. That is definitely discharged. And that now only the battery needs to hold these settings. So now we're going to be turning it on again. And if it now turns on and goes instantly into Windows, the issue is fixed with flashing the BIOS. But it's not properly fixed. It's just that you don't have to go through the BIOS anymore in order to recover settings to then go into Windows. No. And there it is again. I cannot believe it. There is the issue again. It happens again. So the only thing I can think of now is that the SIO needs to be changed. That the SIO has some sort of problem because there's, or the PCH, because there's nothing else connected to the BIOS and keeping the BIOS settings. It's the SIO, the PCH. On AM4 maybe it's only the SIO, I think, because the 3-volt battery is only keeping voltage in the SIO. So I only think it can be the SIO that it is at fault here. But that would just be a guess on my side, to change out the SIO in this case and try with that. There's nothing else I can think of why the BIOS settings are not being saved. I will have to talk to the customer, or not the customer, but the viewer, if we're going to try to change out this BIOS chip, this SIO, in order to see if that is going to help the problem. But yeah, I'm going to stop the video for now here, because this is already, I have content of 73 minutes and I'm not getting anywhere, sadly. I'm at the same point as I was before. So yeah, let me talk to the viewer, and we might want to decide upon changing out that SIO. So I've been thinking about this issue for quite some while, and I think I've for now found a reasonable option. So in this area, I've replaced 2 resistors. You can see that the clear silver solder has gotten a little bit melted plastic, but that doesn't matter. It only looks bad under the microscope. If you look at it from afar, you don't really see it. But now you can see a resistor there and a resistor there. These are both 0 ohm resistors that I've changed now. So we had the problem that we had, this is a 1.5 volt linear regulator. 3 volts coming in, 1.5 volts coming out, 1.5 volts there, 1.5 volts there, and so on and so forth. And I was thinking, if you're shorting these two pins, you expect the BIOS to be reset. So the BIOS has to be something to do with these 1.5 volts connected to there. So we had the problem that we had 1.5 volts, 0.7, 0.6 volts at that point. Because there's normally a 10k ohm resistor and a 1k ohm resistor there. And obviously this line is drawing too much amperage through those resistors, and the voltage is dropping. So I went ahead and installed 0 ohm resistors. And now if we take a ground and we take our probes, we have 1.5 volts here, 1.5 volts there, 1.5 volts at the middle right there, and 1.5 volts there, because this is all 0 ohms. This is basically one continuous line. So the regulator definitely is fine, and it has no problem with supplying that amperage, and it's not getting hot. And yeah, with this fix, it seems to hold the BIOS, the actual BIOS settings. The biggest problem is, I think a few hours ago, I started with 3098 volts. It's now on 3.03 volts. Battery is discharging rapidly. So, what will happen with this board? This board now doesn't get the error message anymore with the BIOS settings having been disabled. But it now has the issue of way too quickly discharging batteries. But this shouldn't be an issue if you keep this thing in standby. So this thing, as we know, around the battery, we have this double diode. And on this double diode, you have here the 3 volts from the battery, and there the 3 VSB coming from the board. And the 3 VSB is always active as soon as you have standby power consumption. So as long as your power supply is in standby, So if your PC is off but your PSU is plugged in, this will deliver 3 volts right there, which means there will be 3 volts at this linear regulator right here, which also means that it supplies voltage to here, 1.5 volts into here. So that means if you once set the BIOS settings, then turn off the system and leave your power supply plugged in like every normal person would do. Like, I can't remember the last time I turned off my PSU. If this is a standard old computer that you use basically every day or something, you won't notice this, because the BIOS settings will be saved via the 3VSB. But if this computer is often plugged out of power, if you turn off the breaker or whatever and turn off the power supply, this thing will have the same issue again. But only once, but only the first time. Only as long as, only when the 5VSB wasn't turned on anymore and the battery discharges. This battery will discharge quite quickly with this now, but we don't get the error anymore. So I will be needing to talk to the viewer and see if that is an option for him, because I do not know what could else be faulty on this. Let's see in the schematic once more for that RTC line. So if we have a look again, this 1.5 volts RTC is our problem. And this 1.5 volts RTC is nowhere else fitted. This is just the output from the regulator. This is just at the this is just the title of the document, and it's here. The only thing where it's going is through this 10 kilo ohm resistor. There's a test point. We have clear RTC, which is only here also, which is the header. VDD RTC-R is nowhere else to be found. And then it only goes into VDD RTC. And VDD, because this is also just a test point. And VDD RTC goes only to a single other place, which is the CPU socket. As you can see, there's VDDP, vCore, everything going in. And there is VDD RTC. And for whatever reason, this board draws more current into the socket, which doesn't make any sense, because it's not the socket drawing the power, it's the CPU that is plugged in that is drawing more power. And like, I don't know if like this capacitor, for example, could be drawing too much out of there, but I wouldn't think so. There's something weird going on here that I cannot explain what is happening. Like, maybe this capacitor is drifting or has some weird fault, or the other capacitor that is on here, but yeah, I don't think so. I cannot imagine that. But something is drawing too much power, and I cannot tell you what it is. Because obviously it should be limited through this 10 kilo ohm and the 1 kilo ohm. But as soon as you limit the current, you get the problem of it not saving the BIOS settings. So I think this is the compromise that you have to take in order to get this board in somewhat of a working state. Because I tell you now, changing out this capacitor or the other capacitor won't do anything. Like, that is not a behavior of a capacitor that it partially, like, these don't go high ESR or something. These are multi-layer ceramics. They don't do something like that. And yeah, that is what we can do for this board. How we can repair it. So I now want to show you the behavior of this board. We now have normal power consumption. We press the power button. We should go into the board, and it should be holding the BIOS settings now, and it shouldn't give us the error. The board was off for like an hour now or two. Okay, new CPU installed. Oh yeah, because I actually did install a new CPU in there. That's why that error comes up. So that is fine for that error to come up. But if we now, I'm now going to turn off the board. You can see power consumption went low. And I even going to turn off the power completely. And now, because the battery is still charged, but it's rapidly discharging, because it's still charged, we're now going to turn it on. And now there's not going to be a issue with the discharging. The discharging problem will be there, but there won't be any error with, the BIOS settings are now being held in here. As you can see, I disabled the SATA ports before and they are still disabled. It keeps BIOS settings now. So the only problem is now that it will drain batteries quicker than it should. But that shouldn't be a problem if you leave it plugged in as normally as most people will do. And there's microamps of power draw there. There's so little power draw there. But that's all I can do, because I cannot figure out where else that current and voltage is going. So yeah. I hope you still enjoyed the video. I hope you learned something. I will leave it like that because I cannot do it better. But I will just tell the viewer how it is with this board. And he will sadly have to deal with it. But because I have tried my best efforts, I'm now at, I think, around 2 hours of footage. And invested about 4 hours into this board. And I cannot go further anymore. This is all I had, and this is all I could give for this board. So yeah, I hope you enjoyed the video. I hope you still learned something with a deep dive into the RTC section, how that is going to work. And I also learned quite a lot about the RTC section. And yeah, all of my tools are as always linked in the video description. Thank you very much for watching. This was Mainbot Medic. Thank you very much and goodbye.